All right, grade 12s, and I guess grade 11s as well. So what we're going to do here today is we're going to finish up briefly the lesson from yesterday. I think I had just a couple little things to finish off, so I'll just finish the couple last little parts of that, and then we will look at lesson 2. So the plan for this week, and I mentioned this to a couple students at the end of class after people had left yesterday, but the plan for the rest of the week is we are going to have, so I'm away actually today and tomorrow. So I have this lesson filmed for today. Tomorrow I'll have lesson 3 filmed and we'll play that in class. I know that some of you will be away for the grad trip. I don't think many of you are away for the grad trip, so hopefully we'll see you tomorrow. But I will have a lesson filmed for tomorrow. I'll post that on Thursday when I'm back. Thursday will be kind of a work period. So I'm going to give you what we're going to do is I'll just kind of take some time to be honest, like do the homework questions, and then I'll take some time to answer any homework questions that anybody has, and to go over things like that. But come with questions. If nobody, right, if we don't have any questions, then we may just continue with the lesson on Thursday. So make sure if you do have questions, or make sure you do attempt the homework so that on Thursday, if we want to have a work period, have some questions to ask. Okay, show me that you've done some of the work so that we can go over some things like that. On Friday, we will have a quiz. So the quiz will be on lessons 1, 2, and 3. So I'm just going to pull that up right now. Lessons. So we'll have a quiz on equivalent trigonometric expressions. The quiz will include compound angle formulas and double angle formulas. So the quiz will be on the first 3 lessons, and then that'll leave the majority, the proving trig identities, and less the solving linear and solving quadratic trig equations for the bulk of the test. Will obviously be a couple questions on lessons 1 to 3 on the test, but the bulk of the test will be on lessons 4 to 6. Okay, so let's get to it because I don't want to take too much time here. So where I finished off yesterday was on the note. I was looking at what is the exact value of cos of pi over 6 and cos of 5 pi over 6, and how were those equivalent. So what we're going to do here is we're actually going to look at the tan of pi over 6, and we're going to compare that to the tan of 5 pi over 6. I'm going to draw that here. So the tan of pi over 6 is, well, remember that's right here. So this little angle here is pi over 6. Okay. This special triangle we looked at yesterday, that's 1 root 3, 2. And tan, remember, is opposite over adjacent. So the tan of pi over 6 is equal to 1 over root 3, which is, right, we change that, we multiply by root 3, multiply by root 3, because we have to have a whole number in our denominator, and that's equal to root 3 over 3. Okay? So that's for the tan of pi over 6. Now the tan of 5 pi over 6, we'll draw that one here. Okay. Well, where is 5 pi over 6? 5 pi over 6 is over here, right? So that means this angle here is 5 pi over 6, which leaves a related acute angle of pi over 6. Now, we did that above, right? If I want to figure out that related acute, it's pi minus 5 pi over 6. You can do that in your calculator or get a common denominator, right? 6 pi over 6 minus 5 pi over 6 equals pi over 6. Okay? Again, we fill in our special triangle, 1 root 3, 2. And in this case, this root 3 is negative. So we say that the tan of 5 pi over 6 is equal to opposite, so 1 over negative root 3, which is equivalent to negative root 3 over 3. Okay? So based on this, we can say that our identity, or like our equivalent expression, is the tan of theta is equal to, so if whatever theta is, that's equal to, and notice here that this one is negative. They're the same, except it's negative. So that's equal to the negative tan of theta, pi minus theta. Okay? So those are equivalent, right? Pi minus 5 pi over 6 is pi over 6, right? And so we get that those two things are equivalent. So what we can actually do here is we can identify equivalent trig expressions by comparing principal angles drawn in standard position in all three of the quadrants. Okay, and we can compare those with their related acute angles, theta. Okay, so we're saying that no matter what quadrant I draw these things in, theta is my related acute angle. Okay, so let's take a look here. So what I'm going to do here is I'm going to kind of draw this over on the side here, and then I'm going to go back to what we had here. Now notice here, just quickly, that notice that all of these previous ones, so in part A, B, and C, we're all looking at the angle of 5 pi over 6, right? 5 pi over 6, 5 pi over 6. Now, where is that angle? That angle is in quadrant 2, right there, right? That angle is in quadrant 2, okay? And that angle's in quadrant 2. So what we did actually here is we already created those equivalent trig expressions, right? We wrote, the first one was that sine theta is equal to sine of pi minus theta. Okay, right? That's what we wrote in part A, right here. Okay, and the reason for that, notice how they're both positive. That's due to the CAST rule, because CAST, sine is positive in quadrant 2. Okay, now we did our second one. We wrote cos theta is equal to negative cos of pi minus theta. Okay, and that's because, right, if we think here, CAST, cos is negative in the S quadrant, okay, or in quadrant number 2. So, in quadrant number 2, our angle, right, is negative. So cos theta, the related acute, compared to the principal angle, is negative. And then we have the same for tan, and tan theta as well is negative in that second quadrant, so pi minus theta. Okay, now when we look at the third quadrant, okay, so let's take a look at an angle in the third quadrant. So let's say here's our thing. We're going to write the CAST rule, CAST, and we're going to draw our angle. So we're going to draw our terminal arm, and this angle right here is our related acute. Okay, right? That angle is related to this angle here. Okay, those angles there are the exact same. Okay, so that's kind of important to note. Now, what I'm going to do here is I'm just going to erase this for a minute, this part, and I'm going to say here that we know that our angle from here to here is what? That angle is pi. Okay, now if I were to continue this a little bit more to my terminal arm, what is that little angle here? We'll make that green. What is that little green angle there? Well, that angle's theta. So if I want to know this total angle, right, and I'll do this in pink, from here all the way to here, what I'm going to do is I'm going to do pi plus theta. So an angle in the third quadrant, okay, a principal angle in the third quadrant is always pi plus theta. pi plus whatever your related acute angle is. Okay? So looking at that, we're going to write that all here. Pi plus theta. Pi plus theta. Pi plus theta. Now, that's kind of the idea of where we got this from. Pi minus theta, pi minus theta, pi minus theta, because in our first quadrant, if we look at our first quadrant, our second quadrant, when I draw that angle here, right, that angle there, our principal angle from here to here, is pi minus theta, pi minus this little angle here, which is theta, okay? So now what we're going to do is we're going to write kind of our equivalent trig expressions here. And we're always going to start with, on the left side, we're always going to start with the sine theta, cos theta, and tan theta. And now when we create these equivalent ratios, all we're looking for is we want to know, is sine equal to, is it going to be negative in that quadrant or is it going to be positive in that quadrant? Because we know, so let's take this back for a minute. We know, so we're looking right now at, right, this angle here is theta. So if I were to take the sine of this angle here, it's going to be positive because all values are positive in this quadrant. Now, if I were to look at the principal angle over here, right, is sine positive or negative in this quadrant, in the third quadrant, quadrant 1, 2, 3? Well, sine is negative there, right, because of the t's, okay? So we're going to write here that sine theta equals negative sine of pi plus theta, okay? Now, same with cos. We're going to say, okay, is cos positive or negative in that third quadrant? And cos is negative in that third quadrant. So we're going to say that cos of theta is equal to negative cos of pi plus theta. And the same goes for tan. Well, is tan positive or negative in that third quadrant? Well, tan's actually positive. So the tan of theta, or our related acute angle, is going to be the equivalent to the tan of our principal angle, theta plus pi. Okay? So these two things are equivalent, tan of pi plus theta. So what we're doing is we're showing equivalent trig expressions. So now what I could do quickly here is I could show you this looking at our graphs, right? So if I go here and I look at, so let's look at this. Let's look at cos, and let's do quick here. Let's do y equals, and we're going to do cos of, what do we want to do? I said pi, so we're going to go pi plus x. So notice here that I said, so notice that I'm going to take off the sign. So let's do this. Okay, so notice that cos of x is not the same as cos of pi plus x, but that's not actually what we wrote. We wrote negative. Notice how they're now the same? Okay, which is what we wrote there. Cos theta is equal to negative cos of pi plus theta. Okay, so those are equivalent. Now you could try that with all of those. Now we're going to finish here by looking at our fourth quadrant. Okay, so I'm going to draw this for our fourth quadrant. Again, knowing that this is our related acute, this is our related acute. So those two angles are the same. Okay, so remember, all values of sine, cos, and tan of theta, this one specifically, are all positive because all ratios are positive in the first quadrant. And then we're going to do our CAST, okay? And we're going to write here that, so we're going to focus on, if I'm looking at, this is my principal angle. So we know that from here to, right, if I were to continue this, here to here, what angle is that? That angle is 2 pi. Now, how do I find just this part? Well, I do 2 pi, and I take away this angle here, which is theta. So this big angle here is 2 pi minus theta. So when I want to write like a principal angle in the fourth quadrant, I do 2 pi minus my related acute. So we're going to write that. We do the same thing. 2 pi minus theta. 2 pi minus theta and 2 pi minus theta. Okay? Now we start with our sine theta, cos theta, tan theta. And all we're doing here is we're saying, okay, which one of those ratios is positive in this quadrant? Well, cos is the one that's positive in this quadrant. Sine and tan are both negative. So we're going to write negative sine, positive cos, and negative tan. Okay. There we have 9 more equivalent trig expressions. Okay. All right, so let's take a look down here now, and we're going to do these 2 examples that I did not get to. So number 1 says, given the following graphs, determine 3 different equations to represent each function. Okay, well, let's do our first one. So notice the first one is basically a sine function. So I can say y equals sine x. Okay, right? It has a period of 2 pi. It has a maximum of 1 and a minimum of -1. Okay, done. Let's try another one. I'm going to do y equals, I'm going to do cos, and its cos graph has been shifted. There's my first maximum, has been shifted pi over 2 to the right. So x minus pi over 2. Okay, we look at cos starts at a maximum. This graph, the first maximum, occurs at pi over 2. So it's a cos graph that's been shifted pi over 2 to the right. Now I want to do another one. Well, let's do this. Y equals, remember, if we write sine and we shift it by its period, we get an equivalent trig ratio. So let's do sine of x minus 2 pi. Boom. That's another one. We shifted it to the right by its period. Remember, there are an infinite number of equations that you can write for that. Okay, so just coming up with 3 doesn't seem too bad when there's infinity possibilities. Okay, our next one. This one's a little bit more challenging because we look at this one and we say, ooh, this one has been modified. Okay, so I'm going to look at 2 things specifically here. I'm going to look at my A value, which is my amplitude. A equals amp. And if I look at my graph here, I can see pretty quickly that my amplitude from my is 2. Okay. This graph hasn't been shifted up. It has a maximum of 2 and a minimum of -2. So my A value or my amplitude is 2. Okay. I also see here that my period is 6 pi. So I know that my K value is equal to 2 pi divided by my period, which is 6 pi. That's equal to 1 over 3. Okay? So if I want to write out a graph or an equation for this function, well, I might start with the fact that this starts at a maximum. Okay? We know that the cos function starts at a maximum. So I'm going to write y equals 2 cos of, what did I say, 1 over 3 pi. Oh, no, not pi. Sorry, 1 over 3x. Okay? Cosine function with my values included there. All right, fair enough. Let's try another easy one. I'm just going to shift this by its period. So I'm going to go 2 cos of 1 over 3x, and I'm going to do minus, and what's the period? It's 6 pi minus 6 pi. So shifting it by its period also gives me a Sorry, I'm going to just change this slightly. I'm going to go x minus 6 pi. Shifting this by its period gives me an equivalent trig ratio. Okay, I'm going to write another one. I'm going to say y equals, I'm going to make this a sine function. Okay, and remember sine starts at the axis. So I'm going to say maybe starts there. So because it starts by going down, what I'm going to do is I'm going to say y equals negative 2 sine of 1 over 3. And how far has that point been shifted? That point's been shifted 2 pi to the right. And there we have 3 equivalent trig functions for that graph. You could put all those all into Desmos. You would get the same thing each time. Okay? Also, I'm going to take questions on Thursday. So please, if you have questions, let me know. I had started example 3 before the bell rudely interrupted us yesterday. So let's see if we can finish up this one here. So this one says write an equivalent expression using related acute angles. So those are basically these 9 things that we did here. So you have a lot of choices for what you could use there. I specifically chose, because we're looking at the cos function, okay, I specifically chose the one where we're in quadrant 4, okay? So the cos of 3 pi over 4 is equivalent to the cos of pi minus 3 pi over 4. Notice how theta, those two values are the same. So what did I sub in for theta? I subbed in 3 pi over 4 for theta. Okay? Now all I'm going to do is I'm going to simplify my right side. So that would be 4 pi over 4 minus 3 pi over 4. And that's equal to cos of pi over 4. So these two things, the cos of 3 pi over 4 is equivalent to the cos of pi over 4. And is that correct? Ooh, I was wondering. Notice here, what did I miss? I missed this negative. Okay, when I'm doing pi minus, I missed that negative there. So this should be negative here. And this should be negative, negative, negative. Okay, so just make sure you copy those out correctly. Okay, so try 3 questions there for homework. Hopefully you tried those last night. If not, take a try today or at some point. Okay, we're going to just continue right on into lesson number 2 here for the sake of time. Okay, so what we're looking at in lesson 2 here, so we're continuing with this idea of, and actually I'm just going to pause it quickly. Okay, I just had to pause that. Fill up my water. It's a lot of constant talking while doing these videos. So, trigonometric equations and identities, again, is our unit, okay? In our previous lesson yesterday and then continue today, we were focused on creating equivalent trig equations. So, basically saying that sine of theta is equal to sine of theta plus 2 pi, okay? Those two expressions are equal, okay? That was the idea of yesterday's lesson. And what we did is we created a whole bunch of them, right? If we look back just quickly, we can see that we created 9 here, 9 equivalent trig expressions. We created 4 more here, so that's 13. We created, where are they here? We created 3 more here, so 16. And we created, well, these ones were basically an infinite number. So what, 16 plus infinity, right? If we just add our period. Oh, wait, where were they? These values here, right? Plus n, right? So 16 plus 3, we'll say, instead of infinity. So we created 19 equivalent trig expressions yesterday because of the way, like, the kind of the foundations of, or where these things come from, there's tons of possibilities for when you're creating equivalent trig expressions. Okay. Um, so today what we're going to do is we're going to kind of continue working with that. And we're going to look at what we call the compound angle formulas. Okay. Now, if we think of compound, right? Compound angle formulas. So what we think of is we think of things that are kind of added together. Okay. And a trig expression. So we'll write this here. Or sorry, we'll read this first part here. But it says a trigonometric expression that depends on two or more angles is known as a compound angle expression, right? We're putting two angles together to create a compound angles. You can think of in chemistry, maybe you have compound elements. I don't know much about chemistry, but I think that compound elements are when you have multiple elements put together to create new elements, I think. A compound angle is an angle that is created by adding or subtracting two or more angles. Okay, so that's the idea of compound angles. It's when we add two or more together. Now, in this note here, this first page is the proof of how the compound angle formulas are created. Okay, it is not expected that you know how to prove these formulas. Okay, but I'm just going to briefly go through it, just briefly, kind of to explain some of the key components of this proof. Okay. So in math, basically the idea is if we want to create formulas, we first have to prove that they're always true. Okay. So the idea here is that we got to figure out how do we actually show that these compound angle formulas are true, and we do that through what we call a proof in mathematics. Okay. And to prove things, we need to use often other formulas or other laws that have already been proven true. And we know, and you know from grade 10, okay, that the cosine law is one of the laws in how we determine, we use the cosine law to find angles in scaling triangles, okay? So it says here, first of all, I'll just read the cosine of a compound angle, a minus b, can be expressed in terms of the sines and cosines of a and b. So it says here, consider the following unit circle diagram. So it gives you a little diagram here, and it shows it's looking at two angles. It's looking at angle B and angle A, and then angle A minus B. Okay, so just kind of looking at that there. Okay, and then what it does is, because this is a unit circle, it knows that the side lengths of your triangle, this side here is 1, and this side here is 1. Okay, and it uses those ideas to help kind of show you in the cosine law. So you see that 1 squared plus 1 squared, those are those side lengths, minus 2, 1, 1 cos of A minus B, okay, is how we find side C, or C squared. So it has that component, and what it does is it kind of simplifies that idea to create an equation for C squared, which is the length that side squared. However, C has endpoints, right? And we know this from when we're writing points in terms of cosine and sine, that your x is always related to your cosine of A, and your y is always related to your sine of A. Okay? And so we have those points. And so what they do here is they create a formula for cos squared. So they look separately and look at a formula for for C. And the formula for C is a distance formula, okay? Between 2 points, distance between 2 points. And then what they do is they go about simplifying that expression to come up with this expression here, okay? Now, I know that I may be losing you. So I'm not going to spend too much more time on this. If you want more of an explanation of this proof, I can go through it with you in class. Again, you do not need to know this for the purpose of this test. They then equate these two equations, equation 1 with equation 2, and simplify and isolate for cos A minus B. So in all of that algebra and equating and isolating for variables and maneuvering and manipulating things around, they come with this nice up with this nice little equation for cos of A minus B, which is equal to sine of A sine of B plus cos of A cos of B. So basically what that's saying is that if I'm subtracting two angles and I want to know what the cos of those are, I have a formula that I can break it down. Okay, it's kind of like expanding a little bit. Okay, and we do in a similar manner, we can create more of these formulas. So the idea here is that we have what are called our compound angle formulas or our addition and subtraction formulas. And these are them, okay? There are 6 of them, all right? You will be given these for a test. So there's 1, 2, 3, 4, 5, and 6, okay? There's 2 for cos when you're subtracting two angles, 2 for, 1 when you're subtracting, 1 when you're adding the angles. There's 2 for sine, 1 where you're adding and 1 where you're subtracting, and 2 for tan. Again, 1 where you're adding and 1 where you're subtracting. And what we can do is we can use these addition and subtraction formulas to solve questions, okay? So that's kind of what we're going to do right now, is we'll go through some examples of how do we now apply these addition and subtraction formulas. So it says here, and I'll just read through this here just for you, and if anybody wants to copy this down, it says that compound angle formulas can be used both forward and backwards to evaluate and simplify trigonometric expressions. By expressing an angle as a sum or a difference of angles in special triangles, so we're relating back to special triangles, exact values of other angles can be determined. Compound angle formulas can also be used to prove the equivalence of trigonometric expressions. Okay, so here we go. So the first question here, it says simplify the expression below. Okay, well, let's simplify this expression. So notice here that we have sine of pi over 3 plus cos of pi over 4, sine of pi over 3 cos of pi over 4 plus cos of pi over 3 sine of pi over 4. So what I want you to notice here is that we have 2, right, pi over 4 and pi over 3. All right, now what we're going to do is let's look back at our expressions here. And so this is sine cos, cos sine, and plus. So sine cos, cos, cos sine, but there's a plus. So this is our expression that we're going to use to simplify this. Okay? Because again, looking at this, we have sine of an angle, cos of an angle, plus cos of an angle, sine of an angle. Sine of an angle, cos of an angle, plus cos of an angle, sine of an angle. So what we're going to do is we're going to write that expression down here. So we're going to write this. So sine of A plus B is equal to sine of A cos of B plus cos of A sine of B. Okay, so we look at this and we say, well, what is A? A is going to be our pi over 3. And what is B? B is going to be our pi over 4. And so what we can do is we can actually write that in our simplified expression, which is this expression right here. So we can simplify that to, and what we'll do is I'm going to write it this way. So we're going to write this expression here. So we're going to write sine pi over 3 cos pi over 4 plus cos pi over 3 sine pi over 4. That's equal to the sine of pi over 3 plus pi over 4, and that's equal to, well, let's simplify this. So it's really important that we understand common denominators, okay? Adding and subtracting fractions in this course because we are going to be doing that a lot, okay? So what we end up with here is we end up with the sine of 7 pi over 12. Okay, so what we've done is we have simplified the expression below. So we've written it as a single trigonometric ratio. Okay, the sine of 7 pi over 12. That's all we needed to do in that one. Okay, so we look at our expression. We see, can I write that in a simplified form using my addition and subtraction formulas? You're basically playing a matching game. You match it and then you simplify it. Okay? Now, that's going in one direction. Now the question becomes, how about we try and go in the other direction? So if I'm given something like sine of pi over 12, and I want to find what the exact value of that is. Well, what we notice right away that this is not a angle from a special triangle. Okay, this is not an angle from a special triangle. So we can't really determine the exact value of this. Okay, so in order to do it, what we want to do is we want to say, okay, well, can I make it special triangle? Can I make it a special triangle? Okay, or two angles that I know more information about? Well, yeah, I can. Okay, I can actually, what I can do is I can look at pi over 12 and I can say, well, what values, and remember, this is like 1 pi over 12. Uh-oh, I'm going to pause this for 1 second. My computer froze. Okay, so I'm just going to do a quick little reset. Maybe you can still hear me. Maybe you can't. There we go. We are back. So what I want to do is I want to break this down into two angles. Okay, angle 1, and let's call it angle A and angle B. A and B. I want to break this down into two angles. What I notice right away is that I have to get 1 over 12. Okay, so I'm probably going to be, sorry, I'm just going to erase those and fix those. It's going to be A, it's going to be B. I want to get 1 over 12. So what I'm going to do is I'm going to try to figure out what are two fractions over 12 that if I add or subtract them, I get 1 pi over 12. Well, I know I'm going to have to do pi over 12, pi over 12. Okay. Now, the idea here, so this is where, our mental math is kind of comes in handy here. Okay, or can be important because we're trying to work in reverse. Okay, we're trying to find two angles that add together or subtract to get us 1 pi over 12. And we want those angles to be either, so this is where this becomes really important. We want those angles to be either pi over 6, because that's in a special triangle, pi over 3, because that's in a special triangle, or pi over 4, because that is an angle from a special triangle. Okay? So looking at those pieces of information, I can see that, well, 4 pi over 12 minus 3 pi over 12 is 1 pi over 12. And actually, 4 pi over 12 simplifies to pi over 3, and 3 pi over 12 simplifies to pi over 4. Or sorry, pi over, what am I doing here? Divide by 3, yeah, pi over 4. Okay. So I divide by 4, yeah. Divide by 3, yeah. Okay. So we can see that, right? So now, look at this. These angles I know lots about because those angles are from my special triangles. So hopefully you weren't expecting to get away from your special triangles because those still are here in this chapter. We still have to deal with our special triangles. So 1, 1, root 2 is our first one. And our second one, we'll go pi over 3, pi over 6, and that's root 3, 1, and 2. So watch how this works. So the sine of pi over 12, okay, so we're going to write that here. The sine of pi over 12 is equal to the sine of pi over 3 minus pi over 4. So what I've done is I've created a compound angle, adding or subtracting two angles. Now, well, we know how we have some formulas for those. So let's go up and look at sine when we're subtracting. So sine when we're subtracting is this one here. Okay, it's sine of A cos of B minus cos of A sine of B. So let's simplify that. So this is equal to the sine, this is our A, this is our B. So the sine of A, pi over 3, cos of B, pi over 4, minus the cos of A, which is pi over 3, the sine of B, which is pi over 4. Okay, notice how we've written this in expanded form with our angles in there. Okay, now we know the values of these. We know what sine of pi over 3 is. We know what cos of pi over 4 is because we can look at our triangles. Okay, so specifically here, the sine of pi over 3. So we look at pi over 3. Sine is opposite over hypotenuse. So root 3 over 2. Okay, so this is equal to root 3 over 2. We know what cos of pi over 4 is. Cos of pi over 4 is adjacent over hypotenuse, which is 1 over root 2. Okay, looking at pi over 4 and adjacent over hypotenuse. We know what cos of pi over 3 is. That's adjacent over hypotenuse in my special triangle. So again, I'm referring to my special triangles here. And I'm using SOHCAHTOA. And I know what the sine of pi over 4 is. That's 1 over root 2. So we can simplify this. Multiplying fractions is top times top, bottom times bottom, top times top, bottom times bottom. Notice these have a common denominator, so we get root 3 minus 1 over 2 root 2. Okay, now my last step here is I do not like to have a root on the bottom, okay, because our denominator needs to be a whole number. So I'm going to multiply the top by root 2 and the bottom by root 2. And what that does, okay, now make sure here, this is being multiplied by both your terms there. What that does here is that gives us a solution of root 6 minus root 2 all over 2 times root 2 times root 2, which is equal to, and that bottom, if you put that into your calculator, you get 4. And that is our solution. That is an exact value. Okay. All right. So let's do another one. So now again, what we're going to do is we're going to break down our angle. So what we want to do again, so I'm going to write here, we have pi over 6, pi over 4, and pi over 3. Those are the angles we want to work with. Notice how this one's over 12. What we can do is we can actually make these all over 12. So 2 pi over 12. 3 pi over 12. and let's go 4 pi over 12. Okay. So what values can actually work here? What values can give me um, negative 5 pi over 12? Well, let's try that. So actually, just let me pause it for 1 second. Be right back. Okay, so I actually just had to check a quick note because I did this differently last year, and I just wanted to point something out here. So let's go back to that question. And notice here that what we're doing is we're looking at the cos of negative 5 pi over 12. And what I thought from it, I thought, well, just let me go check our equivalent expressions from yesterday. Because I think there's something that said that the cos of an angle A is equal to the cos of negative A. And I think that has something to do with the cos function being an even function. So I just went back to my note from yesterday and I looked here and I did find exactly that, right? Because cos is an even function, the cos of A, or any angle, is equal to the cos of the negative of that. So watch this. So what we can do right off the bat here is we can say, well, I know that the cos of negative 5 pi over 12 is equal to the cos of 5 pi over 12. Well, that's a good start because I've already gotten rid of that negative, and that makes that a little easier. And now I know that, well, 2 pi over 12 plus 3 pi over 12 is 5 pi over 12. So I'm going to rewrite that as cos of 2 pi over 12 plus 3 pi over 12. Well, that's equal. That's equivalent, right? These are still equivalent. I haven't actually changed anything yet. And I know still that these are equivalent to these, right? Pi over 6 and pi over 4. So I can say that the cos of pi over 6 plus pi over 6 plus pi over 4 is still equivalent. So all I've said right now is I've just modified my expression to work and deal with things that I know. And now I have an addition equation or a compound angle formula that involves two angles which deal with the special triangles. So again, I'm going to quickly draw those special triangles for you because they are super important, right? Hopefully we've been working with them enough that you're starting to get them memorized. Okay, again, I will give them to you on a test, but this stuff, as you can see, is a lot easier if we know what these angles are, or we have this in our heads. Okay, now what I'm going to do is I'm going to scroll up to my compound angle formulas. I'm going to look for cos of plus. Scroll up, I see, cos plus is cos A cos B minus sine A sine B. So cos A cos B minus sine A sine B. So I'm going to write this as cos A, right? This is A, this is B. So cos A cos B minus sine A sine B. Now I figure out using my special triangles what all of these are. Cos of pi over 6, and I like to just, sometimes I even just like to put these brackets in here just to start. I know they're all going to be fractions. So the cos of pi over 6 is adjacent root 3 over hypotenuse. The cos of pi over 4 is adjacent over hypotenuse. The sine of pi over 6 is opposite over adjacent. And the sine of pi over 4 is opposite over, sorry, I said adjacent, I meant hypotenuse. Okay, so here, I think we actually end up getting the same thing, which is kind of funny. Yeah, we do. I don't know why I have two of the same ones in the note, but again, you can see that the idea is still the same. We get 3 over 2, minus 1 over 2 root 2. And we know from earlier that that's root 6 minus root 2 over 4. Okay, because we did that earlier. Okay. Example number 3. Show that, interesting. Show that the formula cos A minus B is equal to, and that show that this is true for this, when A is pi over 3 and B is pi over 6. So let's try this out, okay? So in this one, I'm going to strictly do left side versus right side, okay? So that's how I'm going to do this one. So I know that, so let's focus on my left side, and let's focus on my right side. Now, anytime we're asked to show something is true, we kind of want to break it down and work on left side, right side. Okay, so let's do my left side first. So like cos of A minus B. All right, let's figure out, well, let's sub in what A is and sub in what B is. So that's pi over 3 minus pi over 6. Okay, I want to subtract fractions. I'm going to get a common denominator. So that's cos of 2 pi over 6 minus pi over 6. Okay, let's subtract those fractions. That's cos of, pi over 6. Oh, look at that. That's a special triangle. Pi over 6, pi over 3, root 3, 1 and 2, and cos of pi over 6 is adjacent, which is root 3 over 2. All right, that's what we got for our left side. Let's take a second now and see if we can get the same thing on our right side. So let's do this side in blue, and let's do this. So we're going to say, okay, well, cos A, cos B, plus sine A, sine B. All right, let's sub our values in. So we're going to go cos of pi over 3, cos of pi over 6, plus sine of pi over 3, sine of pi over 6. Okay. Sorry, let me add my equals. Okay, well, let's figure each of these out. Again, look at this. It's our special triangles. So the cos of pi over 3, well, that's our angle here. So it's adjacent over hypotenuse. So that's 1 over 2. Okay. Cos of pi over 6, so that's this angle here, and that's adjacent over hypotenuse. So that's root 3 over 2. Okay. Plus sine of pi over 3. So ignore all my circles here, because whatever, I made a mess there. So let's redraw this. Try that out. 6 in there, 3 in there. So again, hopefully you're getting the hang of using those special triangles in SOHCAHTOA, because that's all we're doing here. Okay, we're just figuring, okay, what are my ratios? Opposite over hypotenuse and adjacent over hypotenuse. So this is sine, so this is going to be root 3 over 2, okay? And then sine of pi over 6, well, that's 1 over 2. All right, here we go. Let's do some multiplication. We get root 3 over 4 plus root 3 over 4, okay? Well, that's like 2 root 3's, right? That's like having 2 root 3's over 4, because our denominator stays the same. And if I reduce this fraction, let's say I divide the top by 2 and I divide the bottom by 2, I get root 3 over 2. Those two cancel out. And look at that. They're the same thing. So left side equals right side. Right side equals left side, depending on the way you're looking at that. And I think, look at that. We got, 3 more examples. Okay. I'm going to roll through these. Let's see how much time we're at, because I'm always curious of that. Oh, boy. Where is my video happening? Here it is. Okay, 54 minutes. All right, I got about, let's see if I can do the rest in about 10 or less. Okay? Got 3 questions, 10 minutes. Okay. Oh boy. If sine, interesting. if sine of A, oh, I love this stuff. If sine of A, okay, so very, very important here. This is telling us we don't know what the angle is. We do not know what the angle is, but it's telling us that the sine of A is equal to -4/5. Notice we do not know what angle A is. It does tell us that A is between pi and 3 pi/2, but we don't know what it is. That's okay. It's telling us the value of it. So it's telling us the value of sine of A. Okay? It's also telling us the cos of B. Okay, it's not telling us what this angle is, but it's telling us that the cos of B is -5/3. And it also tells us one other piece of information about B. It says that B, the angle B, is between pi/2 and pi. Okay, interesting. All right, so what we're going to do here is we're going to break this down into two parts. Okay, we're going to look at angle A. Okay, so here's angle A. Angle A, we don't know where it is, but we know it's between pi and 3 pi/2. So we know that that angle is somewhere in here. So I'm just going to draw a little terminal arm. We don't really know where that angle is, but we're going to draw a nice little terminal arm there and kind of just use what they're telling us right now. Okay, so we're going to use what they're telling us. Now we know from last unit that sine is y/r. Interesting. Okay, well, we know then that sine is y/r, so that means that this value here is -4, and this value here is 5. Okay, well, if I know anything about this type of triangle, this is a right angle triangle, and we can use right angle theorem to solve for this missing side. So I could do a little a squared plus b squared equals c squared to solve for that missing side. Okay. And if we do that, okay, we find that that side is, I'm going to erase that angle now, and just kind of do a little thing in here. We know that this missing side is -3. It's negative because it's a negative x value, and if I use a squared plus b squared equals c squared, I get 3. Okay? Nice. So this is angle A. So we've just looked at A for now. Okay? Now let's do the same thing with B. I'm going to draw out B. And B, we're going to use this color. B is between pi/2, which is here, and pi. So it's telling us that B is this angle right here. We don't know exactly what it is, but we know that it's somewhere in there. And we know that cos is x/r. Okay, interesting. Well, that means that this coordinate is -5. This is 13. And this one I have to do a little bit. I got to do a little bit of thinking. So I'm going to do 13 squared equals 5 squared plus b squared. That's 169 equals 25 minus b squared. I'm going to bring that 25 over. 169 minus 25 equals b squared. I get 144 equals b squared. And so if I take the square root of both sides, I get 12 equals b. So this is positive 12. Ooh, okay. So now what I've done is I've created two triangles. Okay. I know what, so this is just again, we don't know what that angle is. We could figure out what that angle is by using our trig ratios and taking sine or cos inverse, but I'm not going to do that right now, because what I am going to do here is, because this is what's important here, is that we're looking at our ratios. Okay, notice it up here, we used our special triangles and the side lengths to come up with these values here, to come up with these fractions. We use the side lengths of our triangle, our special triangle. We're going to do the same thing here. So watch this. So it wants to know, what is the tan of A plus B? Okay. Well, I'm going to scroll up and we're going to say, okay, tan of A plus B, tan of A plus B. Holy smokes. That's what the tan of A plus B is. tan of A plus tan of B over 1 minus tan A tan B. Okay, let's see if I can remember that. Okay, so it was, let's write it out. Let's go. It was, so tan of A plus B is equal to the tan of A plus the tan of B all over 1 minus the tan of A tan of B. Okay, all right. Let's try this now. So, watch this. What we know is we've created these triangles, these nice little triangles. And angle A, right, is this first triangle. And remember, tan is opposite over adjacent. So if I look at my first triangle here, here's my opposite, here's my adjacent. So that means, and I'm going to write this here, that the tan of A is equal to -4 over -3. And the tan of B, well, the tan of B is equal to opposite over adjacent, 12 over -5. So I know what those values are. I know what tan A is. Boom. I know what tan B is. Boom. So let's sub all of those values in. And watch. I'm just going to highlight that. Boom. Tan A, tan B. So there's tan B, tan B, tan A, tan A. And I should have a little A in there. All right, here we go. Let's sub them in. So we got, let me just zoom out a little bit here. So we get equals tan A is -4 over 3 plus tan B was 12 over -5 all over 1 minus tan A, which is -4 over -3. And that's 12 over -5. Okay. This is, hopefully you're not having too much fun right now, because this is where we get into some really good fun stuff. Okay, working with fractions at a maximum capacity here. Okay, so let's work with this. So to deal with the top, I gotta go common denominator. So what I'm going to do here is I'm going to multiply the first fraction by 5, the second one by 3. So I'm going to get, and I'm going to also remove those negatives. So I'm going to go 20 over 15, because a negative and a negative is a positive, plus times 3, 36 over 15. And that's a negative all over 1 minus top times top, bottom times bottom. That's 4 times 12 is 48 over, and that's negative over 15. Okay. Whew. All right. So let's simplify some more. Well, 20 plus -36 is 16. Oh, no, sorry, -16 over 15 all over 1 plus, let's actually do this. So let's go 15 over 15 plus 48 over 15 equals -16 over 15 divided by. So if I simplify the top, 15 plus 48 is 63 over 15. Yep. And this becomes -16 over 15 times 15 over 63. These 15s actually cancel out, and so we're left with -16 over 63. And that is our final answer. Oh, I'm just double checking that I did that correct. Yeah, looks good. Okay, so that is our final answer, and that is an exact value. Okay, I don't think I'm going to stay within my 10-minute time frame here, but let's take a look at the next one. So this one says, prove that the cos of pi plus x is equal to the negative cos of x. Okay, so we want to prove this one. So what we're going to do here is we are going to, so we're going to say basically this is A and this is B. So what we're going to do is we're going to go up to my cos of plus. So cos plus. So here's cos plus. Remember, it's this one here. So that's cos A, cos B minus sine A, sine B. So watch this. So cos. So we're gonna focus on the left side right now. So cos of pi plus x is equal to the cos of pi cos of x minus the sine of pi sine of x. Okay? Do we know what the cos of pi is? Well, let's take a look. Right, I always like to sketch out my cos function. Cos of pi, so that's 2 pi. That's pi. Right, so the cos of pi is negative 1. Right here. Cos x. Okay. Minus, what's the sine of pi? Well, let's do a quick sketch of my sine function. This is 2 pi. Oh my goodness, my computer froze. Let's do this. It should still keep working. It did last time. Okay, look at that. That's 2 pi. This is pi. Ooh, the sine of pi is 0. Ooh, that works out nicely. Sine x. Okay. Negative 1 times cos x is negative cos x. Perfect. And 0 times that is 0. So we just proved that my left side equals my right side. Okay. Again, this was a video. You can watch this back. I will be here to answer any questions on this stuff on Thursday. We're going to do this last one here. Okay. So this one says to prove that cos of pi over 2 minus x is equal to sine of x. Well, maybe you can already see where we're going to go with this based on our last one. That there is pi over 2. Okay? Notice that cos of pi over 2 is 0. All right, here we go. So we're going to go cos of pi over 2 minus x. Now, if I scroll up, I'm going to do it just because I just want to make sure. I don't have these all memorized, but I have a pretty good idea. Cos, when we're doing the subtraction, it's plus. So it's cos A, cos B, plus sine A, sine B. Okay? So let's do this one. So this is going to be cos A, right? A is pi over 2, B is x. So cos of pi over 2, cos of x, plus, as you can see, it's 10:06 p.m. and my brain is fading a little bit. So we're going to go sine of pi over 2 and cos of, yeah, there we go. And as I say it happens even more. Keep focused. Sine of x. Okay. Well, again, let's go back up to our graphs. Where is pi over 2? So on cos, our pi over 2 is right there, or 0. On sine, this is pi over 2. Okay? And notice how it is at 1. Right? If you know your cos and sine graphs, which is very, very important. So remember those, right? It's going to help you. Now, you can also type those into your calculator, but you have to show your work here. So cos of pi over 2 is 0. Cos x, right? We don't know what cos x is because we don't know x. Sine of pi over 2 is 1. Sine x. And look at that. This one goes away, and all we're left with is sine of x. Boom. That is equal to that. So our left side equals our right side. Okay? That is all for today. Okay? The homework is there. Give it a go. Okay? Remember, try it out so that on Thursday I can go over some questions with you. Okay. The more questions that you have to ask, show me that you've done it, and then the more I can go over this stuff with you. Okay. If you don't try it, it doesn't help your understanding. So try it, get stuck, because that's, you might get stuck, you might not, but if you get stuck, then at least you know what you have questions about. Okay. Like, well, Mr. Bortolato, I did this stuff and then I don't really know what my next step would be. Okay. It's a better question than I don't know how to do this at all. So try the stuff, have a go. Thursday, we can do a work period. I'll go through a bunch of examples with everyone, and then we will have a quiz on Friday. Okay. Have an excellent rest of your day, and we will see you all on Thursday.